The alert didn't come from a scientist. It came from a machine. During the middle of a routine data sweep-pan, automated pass through infrared scans, radio pulses, and background plasma noise, quantum-trained AI flagged something. Was no dramatic burst, no sudden flare, no flashy signal. What the AI saw was subtle, a stable, consistent orbit circling a planet 124 light-years away. The planet in question was K218b, already marked in star charts as lifeless. It had no atmosphere, no tectonics, no magnetic field, cold, inert, quiet Triton, off as a dead world. And yet something was moving around it. It's not drifting like debris, not tumbling like space junk, orbiting with purpose. The AI didn't hesitate. Its confidence score was 98.7%, not a sensor. Error, not a glitch. This object wasn't natural debris, it was a structure. When the data reached human analysts, the initial response was disbelief. But after multiple reviews, the signal held. The orbit was too perfect. The heat pulses were too rhythmic. The spectral signature too refined. This might not be a message. It might not even be a transmission, but it could be something more enduring. A monument. It's possibly the first we've ever detected. The alert didn't come from a person. It came from a machine, a quantum-trained AI system scanning data from the James Webb Space Telescope JWST in Earth-based radio arrays in real time. Hidden in the heat maps and signal curves, the system had isolated a clear anomaly orbiting K218b, a planet long dismissed as inactive. The object was stable, persistent, and unlike anything previously catalogued. K218b orbits a dim star, 124 light-years away. The planet is cold. No signs of an atmosphere, plate tectonics, or a magnetic field. A fossil of a world, quiet in every known spectrum. And yet around it, the AI flagged an object with a 98.7% confidence rating of artificial origin. That number was too high to ignore. Engineers took it seriously. Astronomers double-checked the instruments. They reran simulations. Still the anomaly held, one researcher remarked. It feels like something had been watching us back this whole time. The data was sent to 3 separate observatories for independent verification. It quickly escalated. What started as a quiet anomaly became a full-scale investigation involving multiple agencies and experts across fields. The object didn't match any known ring system, satellite path, or asteroid orbit. It moved too cleanly. It stayed in a perfectly circular path. It held its altitude. It was simply there. To understand the magnitude of this, we need to ask something basic. What defines a dead planet? What does it mean when something artificial orbits one? In astronomical terms, a dead planet is one with no internal heat, no atmosphere, and no liquid water. These are the essential thresholds for defining planetary activity. In such a world, the mantle doesn't churn. The surface is still. No magnetic field shields it from cosmic radiation. Typically, these are worlds where nothing is left to see. That's how K218b had been classified. Looking at its records, K218b checked every box. No volcanic activity, no reflective surfaces, no clouds, no oceans. Its heat signature was flat, just scattered starlight re-radiated from its frozen surface. Scientists considered it a sterile rock, the kind of place you scan once and forget. It's a control group, not a candidate for discovery, one joked. Gosh, even after combing the JWST archives, there was no indication of anything noteworthy. No past flares, no spectral oddities, no strange emissions. Just silence. That silence is exactly why the discovery felt so alien. We expect dead planets to stay dead. And yet, something was orbiting it quietly, precisely, deliberately, that changed the equation. It disrupted expectations. We tend to think of exoplanets in binary, alive or dead, habitable or irrelevant. But this structure proved that dead worlds can still matter. It's maybe not as hosts for life, but as something else. A base? A beacon? A memorial? If the planet was dead, then the mystery wasn't on the surface. It was in orbit. Which leads to the next focus. the object itself. Its features are unlike any natural formation. Its orbit is circular and synchronized with K218b's slow axial rotation. That kind of station keeping isn't something debris can achieve. It implies intention. The object is estimated to be around 10 kilometers across, small enough to be overlooked by earlier surveys, large enough to rule out coincidence. Spectral analysis shows strange reflectivity, complex alloys that don't occur in nature. These materials bounce back infrared radiation in ways that suggest shaped, engineered surfaces. In addition, the object emits faint but regular infrared pulses. They might be waste heat. They might be energy cycles. Either way, they imply active systems. AI analysis detected station-keeping maneuvers. This thing wasn't just falling into orbit. It was holding it. That requires energy, solar, nuclear, or something we haven't identified yet. But whatever it is, this object isn't passive. It's not tumbling. It's not decaying. It's persistent. As one orbital dynamics expert put, it's too structured to ignore, too deliberate to dismiss. And right now, it's the only thing moving around a world we thought didn't matter. But suddenly, K218b matters more than almost anything else. The discovery wasn't an accident. It was the result of extraordinary processing power, quantum AI. This system, unlike classical computing, used quantum bits to analyze massive datasets from JWST ALMA and ground-based observatories. It wasn't just looking for known patterns, it was built to find what doesn't belong, and it did. It cross-referenced infrared patterns, spectral fingerprints, radio echoes. Over and over, something stood out in K218b's dataset: a repeated pulse, steady motion, a persistent shape. Human analysts may have missed it. AI didn't. It eliminated every natural cause: cosmic rays, sensor noise, atmospheric scatter. What remained was something circular, heat-regulated, and engineered. It assigned a designation: Astro Artifact, 98% confidence. That term had been in the system before, but never applied to anything real. One of the developers behind the AI system put it best: it didn't solve the mystery. No, it showed us where to look. Without it, this object would have been just another data glitch. Now it's at the center of everything. Quantum AI didn't just analyze it, discovered it, changed the very way we conduct astronomy. It pushed the field toward something new: astroarchaeology. But one pressing question emerged: could the object be human in origin? Some wondered if it was lost or forgotten tech. Perhaps some Cold War-era probe flung into deep space. But the math doesn't add up. K218b is 124 light-years away. The farthest human probe, Voyager 1AS, barely 0.02 light-years from Earth. No propulsion system we've ever built could come close to reaching that distance. Not even theoretical ones. Experts combed through every launch registry and satellite catalog, military archives, lost assets. Nothing matched. Thousands of satellites orbit Earth. A few are untracked. But none left the solar system. Even the most imaginative theories, secret interstellar missions, fall apart under scrutiny. Building something that could do that would have left a footprint. Infrastructure, funding. A rocket that powerful would have made headlines, not shadows. As one aerospace analyst stated, if someone broke physics, we'd know about it. So what's left? The conclusion is increasingly inescapable. This isn't ours. It never was. Orbital mechanics don't lie, said one tracking specialist. This object isn't local. It's not lost. It's new. Rather new to us. Of course, this wouldn't be the first time space has teased us with anomalies. There's precedent. In 2015, astronomers puzzled over Tabby's star's light, dimming in strange patterns. People speculated about alien megastructures. But eventually, dust clouds were deemed the likely culprit. A natural explanation. In 2017, the object Oumuamua passed through the solar system. Long and tumbling, it accelerated in a way that comets usually don't. Theories emerged. Some called it an alien probe. But with limited data, consensus leaned toward a rare natural object. Then there were fast radio bursts, FRBs, sharp repeating radio pulses from distant galaxies. First, they seemed like potential signals. Now, we believe most originate from magnetars, dense neutron stars with intense magnetic fields. And then there's the legendary WOW signal from 1977. One blast, never repeated, still unexplained. These examples show a pattern: surprise, hype, and then natural explanation. The question now is, will K218b follow that arc? Or is this time different? Theories have already begun circulating. Some are grounded, maybe it's a natural mineral anomaly, some metal-rich asteroid forming a reflective shell. But the spectral data makes that unlikely. The materials are too uniform, too engineered. Other ideas suggest it's a proban ancient one, something built long ago, now simply circling a forgotten world. Silent, watchful, not a threat, but a testament. Another possibility. It's a remnant of a Dyson structure, a shard from a once massive energy harvesting network. Perhaps this piece survived collapse and drifted here. Some wonder if K218b is the target of terraforming and the structure part of that failed effort. If so, the project failed. Only the scaffold remains. Then there are wilder theories: quantum, bubbles, wormholes, even dark matter interactions. Fringe ideas, but not entirely dismissed. We're in uncharted space, one SETI analyst said. Every explanation deserves daylight until it doesn't. Between broken rock and breakthrough, tech lies a very narrow path, one that this anomaly might be walking.